Hello, this is question 3 from your mechanics paper from June 2022 from Edexcel. It's a variable acceleration question. So you have a fixed point O lies on a straight line, a particle P moves along the straight line, and this is the displacement, or the distance in this case, from O at a time t. Yeah? So it's in terms of t. Find the acceleration of p at each of the times when p is at rest. When p is at rest means that the velocity is 0. So we have to find the function velocity. Remember, when we have displacement in terms of time, if we differentiate, we have the velocity, because the velocity is the rate of change in displacement, and if we differentiate, we have the acceleration, because the acceleration is the rate of change in velocity. So if we want to find the velocity, we are going to differentiate the function displacement, which is this function here. So I have 3 times 1/3 is 1 t squared, minus 5 halves times 2 is 5 t plus 6. So this is my function velocity. It's giving me the velocity at any time. And I want to see when this is 0, to see when the particle is at rest. So I'm going to make this function equal to 0. It's just a quadratic, so if you factorize, you have t minus 2, t minus 3 equals 0, which gives me 2 times t, so 2 seconds and 3 seconds. But they ask me about the acceleration. So I need to find the acceleration, which means I need to find the function acceleration, and for that I'm going to derivate the velocity. So I'm going to derivate this function here. Yeah, so this is dv by dt, which is 2t minus 5. When t is 2, that acceleration is going to be 2 times 2, 4 minus 5, minus 1 meter second squared, and when t is 3, I have 3 times 2, 6 minus 5, 1. So the acceleration is 1 meter squared, second squared. So these are my acceleration. This is my acceleration for the times when p is at rest. For b, they say find the total distance traveled by p in this interval 0, 4. My recommendation with these questions is that you do a quick sketch to see what's happening. If we represent velocity time, so velocity against time, we see our velocity function is just a quadratic, and I know the roots. So my velocity time is something like this. This is 6, the y-intercept. This is the first point, the first root, which is 2, and this is the next root, which is 3. And they are asking me between 0 and 4. Yeah? So if you remember, the area under the velocity time graph is the distance. So if we integrate from here to here, we don't need to integrate because we know the function. But if we integrate function velocity from here to here, we are going to get one positive part. So this one here between 0 and 2. Then we are going to get a negative part. And then we are going to get a positive one again. So if we integrate all together from 0 to 4, we are going to find smaller quantity, because this bit is going to be subtracting from our total. So in this case, what we have to do is to integrate from 0 to 2, from 2 to 3, from 3 to 4, and add them, but all of them positive, because this is going to be negative. We don't need to integrate, because our function velocity is already integrated. It's this one. We know the function displacement. But this function is going to be positive and negative, and we have to be careful with that. So what we are going to do is find the displacement from here to here. Yeah, like if we were integrating, but we are not integrating because we have that. So we are going to do S2 minus S0. Then the next bit that is going to be negative, we are going to subtract it, so it becomes positive, so it's S3 minus S2. And the last one, which is positive, between 3 and 4, we are going to add it positive, S4 minus S3. Yeah, and this is what we do to find the distance. So all the distances must be positive, and in this case, the particle is moving in one direction and then in the other, so the distance, it will be positive or negative. Not the distance, really, is the displacement. but we are going to find the distance, we need the positive value of all of the displacements. So we just need to substitute the values in our function displacement, which is this one here. So when t is 2, to find s2 is when s is 2, I have 1/3 2 cubed minus 5, and that's it. I just have to substitute. So that first value minus s0, and s0 is 0 because t is 0. So this first bracket is just 14/3. Then s3, I'm going to substitute t when by 3. So s when t is 3 is 9/2. Then minus s2, I just found that is 14/3. Plus s4, I substitute by 4 and I get 16/3. And then minus s3 that I just say is 9/2. Yeah. So these distances are going to be 14/3 minus 1/6. You see this second is negative, 5/6, and altogether is 17/3 meters. Yeah, so this is what is happening. This particle, if we find the distance from here to here, it will have some bits that are negative and I'm subtracting. So that's why it's a good thing always to represent the velocity time graph to see what's happening with the particle. Yeah, mainly when we have to integrate. We don't have to integrate here because we have the function displacement, but if we have to integrate, we will have to integrate between 0 and 2 our velocity. Then we will have to subtract the -1, which is between 2 and 3, and then we'll have to add between 3 and 4. Yeah, but this is not the case because we have the function, but that's what we'll have to do in that case. Yeah, and that's all with this question.